We are now going to be dealing with conservation of energy, conservation of mechanical energy, which is different than conservation of energy. And conservation of mechanical energy is actually easier to use than the work energy theorem, but it's considerably more abstract. So to derive conservation of mechanical energy is fairly straightforward. Okay, so to derive conservation of mechanical energy, we start with the work energy theorem. So in my mind, there's not a lot of difference between conservation of mechanical energy and the work energy theorem, because they're really the same coin, but two different sides. One side is conservation of mechanical energy. The other side is the work energy theorem. And so this is what we know. According to the work energy theorem, that the network changes the total, it changes the energy of the system. So then what this tells us here is that what are the possible works that can be done? Well, the network, I could have works that are external. That means that there's an external force. But up to this point, we've been talking about the work of gravity and the work of the spring. And according to the work energy theorem, this changes the kinetic energy of the system. So let's draw a picture of this to make sure that we're clear. So when I have this picture, I imagine that I have some block. And I'm going to say that this block is my system. So then I'm going to go, okay, I'm going to say that the system is this block. So then, what are the forces involved? Well, according to this, that means I would have an external force, that's the force of gravity. I could have an external force, that's the force of the spring, and I can also have maybe some external force, that's F external here. But there's something really special here. The gravitational and spring force are very special forces. Since their workings can define a potential energy function. We can't do that with friction, but we can do that with the spring force, and we can do it with the force of gravity. So then, according to the work energy theorem, we could then say that then the network is then going to be, there's some external work, and then again, I have the work of gravity and I have the work of the spring, but because I can define a potential function, the work of gravity is the change in the negative change of the potential energy. The work of the spring is the negative change of the spring potential. So when I write this in, it then becomes that I have the external work minus the change in gravity, minus the change in the spring, and this has to equal the change in kinetic energy. Now, if we have a system now, if there is no external forces acting on the system, that then implies that the work that's external is zero, then we have the following relationship. So that means that this term right here, we're saying that this term becomes zero. So if I rearrange this thing, it then says the following thing, that I have the change in kinetic energy plus the change in gravitational, and the change in the spring potential is zero. So if you rewrite this, we then get something that reads K1 plus UG1 plus U spring 1 equals K2 plus UG2 plus U spring 2. And what you find here is, because this shows up so much, we then call this the mechanical energy at state 1 has to equal the mechanical energy of state 2. And so we then have the law of conservation of mechanical energy. So the law of conservation of mechanical energy reads that if there are no external workings, then the energy beforehand is equal to the energy after the interaction. And all we have to do, and this always has to remain a constant. So then this quantity will never change if we don't have any external forces acting on the system. This is the law of conservation of mechanical energy. And I would say that this is the most powerful law. So if this is the case, then we have to draw our system different here. So this means this can only be applied if I have my system and in my system there can only be two forces in this system, because the force of gravity has the ability to produce a potential function in my system. If I have a force of gravity, that means I include the Earth into my system, then I can use mechanical energy. If I have a spring force in my system, I can include that and still use conservation of mechanical energy. So this is only valid. So if I use friction, it won't work. If I use any other force, it will not work. These are the conditions right here.